We are done with residential boilers, and we started talking a little bit about industrial boilers. We said they are very similar to residential, just on a bigger scale, different sequence of operation. And I want to get you exposed to some of the terminology and some of the components and what they look like, so you do not get intimidated when you have to work with one of those in the field. It's basically a primary control with on a bigger scale and more capabilities. And really we'll wire in the lab at least two, so you can have a sense of how they are wired and what is the sequence of operation. One of the most common ones, it's very old, but it's still in the business, is the Honeywell R7795, and it's a very simple and good example of that control. So we covered flame rods and optical detectors. I would say a flame rod is a steel rod covered with ceramic or porcelain, and it reacts with what? What in the flame? Ions. So we said flame produces light, heat, sometimes some particles, and also some ions. Ionization is when the matter transforms into plasma. So it reacts with the ions to do identification. What's a rectification system? It's a system that changes AC to DC based on the fact that AC is up and down, plus and minus, and we try to eliminate some of those peaks and combine it to a single stream DC current. Optical detectors, what are those? Give me an example. Thank you. Example of optical detector.
Glasses.
Come on.
Glasses are an optical detector.
Cancel.
Huh? God cell. Two more.
Motion sensor.
Doesn't have to explain. But the same idea. What's has that? What's in motion sensor?
Infrared.
Infrared. What else?
UV.
UV, ultraviolet. And what is the last one? Reduces voltage. Photocells. So I'll write them down so you remember. Optical. So, do we use cat cell in industrial?
No.
No. It doesn't have the limits for the temperature and the amount of flame. And if you noticed, if you read the resistance for infrared for cat cell when it sees a flame, it goes down to zero sometimes. So that doesn't give you a good scale. You want something that will try to give you gauge the amount of flame that you have. So cat cell is not that suitable for industrial. Infrared and ultraviolet, they both produce, are used in rectification system. Which means they change AC to DC. PV is photocells. What does it do? It's produce voltage. DC or AC?
DC.
DC. So your panel on top of the roof, they are producing DC current, and you have an inverter in your garage to invert that DC into AC, or you have batteries where you store that energy as DC, then you dispense it as AC current. So that's DC photocells. What is it? This is a photocell. It's very small. It produces small voltage, and it's little cell here, one of the first ones, and they last for a long time. Again, the same technology, which is basically silicon and copper sandwiched together in different layers with some chemicals, and they react with the photon in the light to produce ions. So we talked about flame rods and optical detectors. We talked about valves and valve trains, and we said what are they arranged on what basis? Valve and valve trains. We have a lot of valves. We have solenoid valves, motorized valves, check valves, pressure relief valve.
Control the flow of fuel,
Yeah.
to combustion.
Yeah, but the amount of the train is decided based on what? The amount of BTU, right? So for each BTU you have different gas train.
These are the size of the boiler and BTU.
Yep. What is the sequence of operation? 5 common steps. Pre-purge, pilot flame, main flame, post-purge.
Checking for flame, right?
Yeah, check for flame, then post-purge. Let me write them down. It's very simple things that I want to keep repeating so you remember them. So first thing is pre-purge. 2,
Lighting pilot.
light, pilot. 3, and when we do the lab, you'll see these tips, and see the lights.
Wait, Father, this the 5 steps do what? Just to check on a burner?
No, this is the operation that happens in the main operation.
Oh, okay.
Yeah, when you turn it on, this is what happens. First, you'll pre-purge, light the pilot,
Proving the pilot.
prove the pilot. Light main flame,
Activate automatic control.
yeah, 5, automatic control. And 6 is post-purge. Purging is more important for gas boilers than oil. Why? Because gas dispense, gas can go over the chamber, and you want to get that out before you start the operation. So, major components, pilot line and the main fuel line. You will see those lines usually coming into the boiler. We talked about those too. Okay. Firing rate control. What is firing rate? It's in GPM, or the amount of fuel you put into the chamber. That's the firing rate. Combustion rate, how much you're burning, how much BTU you get. So if you get the firing rate or combustion rate, that means how much fuel are you burning. And that's why this is how you size a boiler. The boiler is, like, for example, 500,000 BTU. That's the firing rate. It's how much BTU it is producing. The rate at which the air fuel and air fuel mixture is applied to the burner, motor, or furnace. So if you look at this little burner here, what is the firing rate for this? It's based on the nozzle, right? If the nozzle has 1 gallon per minute, how much BTU is in a gallon? How much BTU is in a gallon? Oil. 135. So this is the firing rate, it's 135. Usually it's printed on it, but not usually. But you can always find the firing rate based on the nozzle. It can be expressed in volume, in feet cube, if you have gas. It can be also expressed in weight, if you have coal or if you have oil. So there's different expressions for firing rate. And heat unit BTU per hour. So you'll see a firing rate in volume, and you have to convert that into BTU. You'll also see it in weight for coal or fuel oil, heavy fuel oil, because it's mixed with other substances. So you will see firing rate in volume, weight, or unit per BTU. So remember that, because that could be one of the questions in our quiz. Felipe, phone away, put the phone away. Okay, the purpose of having the controls. So this is a Cleaverbrook control. What is the purpose? Automation. We don't want somebody to be there controlling the fire rate the whole time. We don't want somebody to gauge the fluid coming in and measure the air. In our residential burner, how do we adjust the air? By hand. How do you change the firing rate? By hand. You have to go and change the nozzle. So a lot of things are done manually. How do you change the pressure? Again, by a screwdriver. So a lot of things are done manually, and they are set at one single firing rate. In commercials, we can do all these things remotely, and we don't have to go and interact with the equipment. So, we want to simplify the operation. There used to be a time when the boiler room had people in it shoveling coal into the chamber. We had, even recently, within like 20 or 50 or 25 years, people will be in the firing room, and the control guy in the room will say, yeah, we increase the firing rate by 25%, and somebody will open the valve by that amount of fuel, and they do some calculation right away. And there used to be at least like five or six people in the boiler room, people in the control room to control the pressure coming out. So it was very heavy operation. Now a lot of things are automated. However, by law, there always has to be somebody in the boiler room to check the valves and the machines and the pressure, because it will be faster for somebody to be there to shut off the valve on fuel, and sometimes the control may not work. You never know what could be the problem. Did everybody have anybody been in a marine ship, like whether for the army or for a cruise ship? So if you go to in a cruise ship, they will give you a tour of the boiler room, and it is something that you will. Something you have the exact.
I've seen it on TV.
Yeah.
For a person.
So they still have boilers and diesel engines in big cruise ships, and they will need somebody who will be with second fireman license to be operating that room, because you're burning a lot of fuel.
Yeah, they said them fishing trips where they go and get the lobsters in Alaska. That's been on A&E or History Channel for a long time.
And you need somebody with a diesel engine license. We want to reduce the operator load. If it's more economical to have an automatic control. Why? Because you can gauge the fuel properly based on the load you need. When you drive your car in the highway, they tell you the best way to save gas is to put it in cruise control. No matter how sensitive your foot is to keep the speed at 65, the cruise control will do a better job than you into gauging the fuel and the speed. So the same thing for the power plant. If you want to get the constant firing rate, it's always better for you to have automatic control. Also, steam pressure. We want to gauge the steam pressure because you don't want to have excess pressure. The more pressure you have, the more strain you'll have on the system, especially if it was not ready for it. And you also want to control the air-fuel ratio. So that's another thing. If you have a constant flow rate, you have to go and control the flow by hand, or open it or close the damper. And that's what we did here. This kind of represents the damper, and you have to go and whenever you change the fuel type, you have to change the air. And that will also going to give you soot. So imagine what would that be like if you have to do it many times a day. So we want something to control the fuel. The draft. Draft is the air coming in and the air coming out. You also want to control how much air and exhaust you are dispensing into the environment. For big steam boilers, water level is very important. Why? If you run out of water, you risk the problem of explosion or overheating. Who was here on last Thursday? We had one of the steam boilers running in low water, and suddenly the relief valve just deployed. So that's actually good that the relief valve worked. 30 psi was the limit, so probably we reached 30 psi, and luckily the relief valve deployed. So probably that boiler had some low water or had low circulation. So you always need to monitor the steam pressure and the water level. As soon as the water level decreases, you're gonna have a lot of issues, because water takes a lot of energy to heat. But once you have hot water, steam will start rising quickly. Does anybody have steam here at home? Yeah. You turn it on. From cold, it takes like 20 minutes to kick in. After that, it will quickly heat the house. You'll hear the steam. You hear the air coming out of the vents. Steam takes over, and it will keep producing steam slowly. So you want to control the steam temperature and pressure. As you increase the steam temperature, the pressure will increase, and as the pressure increases, there's a lot of force acting against the walls of the radiator and the pipes. If you exceed the steam without relieving some of the excess pressure, you might cause a burn in the pipe. Steam pressure is very, very fatal and very important, and never underestimate the power of steam. In power plants, actually when we did the tour in Ludlow plant, they said like back in the days when they used to have to go and do the walk around the plant, somebody had to walk with a steel rod before they step. Why? Yeah, because sometimes there'll be a small, tiny, minute, hair-sized leak that is so strong and so fast that can cut off the rod. And one of the operators said that happened to him once. One of the gaskets would be leaking steam so fast and so hot, and the steel rod he was walking, he was cut in half. So never underestimate the power of steam. That's what happened in his leg. So this is how fast and strong the steam flow was. But luckily now we have the steam monitor everywhere, and we have pressure sensors everywhere. And how do you know if there's a leak? Here's a general rule. Before and after any big gasket or valve, you put a pressure gauge before and after, and you send sensors to the control room. That's what the person in the control room does. He monitors all those pressures, and they set an alarm. If this pressure goes lower than this one, sound an alarm, because that means there's a leak. So this is how you know how much you send and how much you receive, and if something is missing, there's a leak at some point. So there are a few methods to control firing rate. You can control it by hand, open up more flow, and adjust the air. It's something called base load. Base load is very interesting. Probably you'll see that in big commercial buildings. So in base load, and probably you'll see it also in some residential buildings. We'll have 3 of these burners together, or 3 boilers together, and we turn one on off based on how much do we need. So if you go in the shop and look at the HP Smith, the big ones, they have 3 nozzles. So we can turn 1 nozzle, 2 nozzles, and 3 nozzles. So that is convenient in a way, but also it could be a little wasteful, but it's still a way to do it. So if you have a lot of flow, I will turn 2 boilers and 2 nozzles, and cut them off on and off. So that's one way to do it. There's also something called automatic MDM, motorized damper motors, which what it does is I will increase the flow rate based on how much I need in the same nozzle, and based on the fuel rate, I will adjust the air. So either by hand, base load, on and off, 1 nozzle, 2 nozzles, 3 nozzles, 1 boiler, 2 boilers, 3 boilers, or I can do an automatic flow of either gas or oil and adjust the air using automatic damper.
What does the MDM stand for?
Modulating damper motor. We'll talk more about it and we'll show a picture too. So parallel control, steam, pressure change. So when since the pressure have exceeded, for example, 15 psi or 50 psi, again I'm talking commercial now, not residential. What is the maximum operating pressure in residential? 2. What is the pressure in the boiler? It can be up to 15. We did that last Thursday. It could be up to 15 psi, but the pressure in the system should not exceed 2 psi. So we monitor the pressure, and based on the pressure, we send the signal to the fuel pump to increase the fuel. And the more fuel you'll get more pressure. And the modulator will increase the air flow. So signal sent by the pressure will increase the flow, and the flow will be connected to an air damper that will open and close the air based on the fuel rate. Make sense? So method of firing. So we have continuous firing, which is like you can find that out in dryers. So in a clothes dryer or big dryers, you have the fire rate that's always continuous, either on or off. Nothing will change. The airflow will change, but the fire rate will be always constant. On and off. This is for economical burners. When it's hot, when it's cold, when you need some heat, you turn it on, or you turn it off. And also we have high and low firing rate. So you keep the boiler on the entire time, and you have high rate and low rate. So between those two, you can modulate between those two. And also we have modulating. Modulating can give you like different numbers. So let me explain that a little bit. So for continuous firing rate, it will be the same firing rate. For example, 100,000 BTU. On and off, it will be the same thing, but it will be off. You go up, off, as long as you need. So and this is again on and off, and it will cycle back and forth. So you might need something in the middle here, and you just keep turning it on and off, which is okay, but again, it's not ideal. High and low fire you can have again. $100,000, $200,000. So you can go to up here, here, and off. You go back again, top, low, and off. You can mix and match high and low depending on the demand, and or you can have modulating flame, where the flame will go up and down as you need it to be. Let's say this is 100,000. So you can adjust the flame to be, this is the firing rate.
Continuous fire, that's in clothes dryers, right?
Yeah. Yeah. So you can modulate until you get the right amount of flow and balance it this way. So this is called the modulating motor damper. It's a device basically mechanical. It works in a cam. What's a cam? We all hear about camshaft and cam valve, and double cams, twin cams.
Like an egg shaped, or some kind of odd shape that spins on the center of the shaft
Yes.
to give
It's
a
a-
motion to another object.
Yeah, I will show you a demonstration. It's this is what it is actually. We provide timing by having an odd shape, egg shape gear. So a usual gear looks like that. It's concentric. Cam will look.
You can put gears on that too if you want to get real fancy.
Yeah, there is. This one has gears on it. So what happens is, as it moves, there is timing with. So the main point of having a camshaft is you turn it when I'm close to it. You turn and push, then when it steps away, it's not turning. And this is how your car modulates between inlet and outlet. You have a cylinder, as it goes up, two valves open to bring in the fuel and air mixture. As it goes out, it closes those two and opens the other two. So it's a timing gear. So now if somebody asks what, huh?
The engine that is itself a cam,
Yeah,
the rotary.
it is. But it also have, there's also some cams coming in and out for the top of the motor. So this is the modulating motor that we have. If you see the linkage here, these are the linkage that correlated to the firing rate. So as we control the firing rate, we also have the corresponding air damper coming in with that firing rate. What does it do? It connects the mechanical linkage to the open and closed fuel valves and air dampers of the burner. If you look at YouTube and look up a car camshaft, or if you go to the automotive department, you can see that happening up and down. But we can see also what we have for mechanical dampers here. It's very interesting technique to time while you are rotating something and have a ratio. So if we have a ratio for a damper motor, this is a cam here. This is one side and this is the other side. It's the main, this is the entire gear. These are the teeth. So we also control the timing. The one circle here is different timing. It will touch at some point, it will turn away, and turn back again, turn over and over. So it's timing. Yeah, I think I have a small animation here to explain that. Provide proportional control of its firing rate. Shaft at the modulated motor operates the linkage as it rotates within an arc of 90 degrees. So it will go up and down at 90 degrees. This is what you see inside the modulated motor. These are the cams, and you can see they are kind of odd shaped. And this is the transformer, and this is for the high firing rate and the low firing rate. So it will go up and down and change the mechanical linkage connected to it from the outside. So this is a simple animation of a camshaft in the car, and these are the two cams coming into the motor. This is connected to the motor crankshaft, so it spins with the same speed the motor spins, and these will modulate which opens and closes at each time. So as fast as the engine runs, the faster you'll have flicking up and forth between those two camshafts, cam gears. So what happened if one of them is offset? The car's not going to run smoothly. You're going to have smoke coming into the exhaust, and it's a big issue. So that's one of the biggest things when you do an engine overhaul is make sure you don't mess up the timing though, or the timing counts. But these are very sensitive, and they are, how many times they open and close? If your car running at 2,000 RPM, how many times do they close and open? 2,000. 2,000 times a minute. That's a lot. So every small misfire will be an issue. And sometimes, since if you're in an engine,
500 times for each one.
500
It's
times?
only for every rotation, or the RPMs, I think that's measured one complete cycle.
for the engine.
Yes,
In
so
and
one
down.
complete cycle of the engine will be 4 cycles of that, it's a forced stroke.
Depending on how many cylinders do you have.
So, yeah.
A complete cycle of the engine. So let's assume that it's a one cylinder and it's going at 5,000 times. This thing will go up and down 5,000 times. And sometimes, do you even notice that the engine will flutter at low RPM, and when you hit the gas, it goes away? If you have a misfire in the engine, one of the cylinders is not running correctly. At idle speed, it will flutter, but if you hit the gas, it will smooth out. And that's because you're reducing the time when the cam actually is open and closing into the engine. Okay, so some of the most common problems when it comes to the main control and the camshaft or MDM is the firing, is the faulty electrical components. So we did that a lot. There's something that's not connected correctly. Mostly loose connections, they do come loose. So always go and check the wire nuts and check the wiring for integrity. And those wiring are press fitted. You don't find a lot of wiring nuts. Dust can be a problem with the MDM because it will go inside the MDM box and clog the gears. Corrosion or moisture that can impede the linkage when moving slowly. So these are the most current problem. Pipe and downs. Pipe and down. I need to know that for the quiz. Oh.
You writing this down here?
Yeah. Quick doorway. Okay, loose connection, dust or corrosion from the moisture. Other problems you might have with the MDMs and firing rate control is failure of resistor board that's inside the board, and a lot of those connections have a resistor, and those resistors are to control the flow of amperage going to the components. So we noticed that according to Ohm's law, if I have constant voltage voltage equal resistance times amperage. So if this is constant, and I want to reduce the amperage, what do?
Use the resistance.
Increase the resistance. That's why we have resistances in the board. So this resistance will impede the flow.
I get it now, I didn't get it before.
Yeah. So that's why you will have a lot of resistances to control the flow for each one of those. I'll put it again over here. So Carlos, if I keep the voltage constant here, and I want to decrease the amperage, what do I do to the resistance? Exactly. If I want to bring this down, I'll have to increase the resistance. And the same thing, vice versa. If I want to increase the amperage, I will decrease the resistance. This is what is happening in the cat cell. Has high resistance, no amperage going through to turn on the boiler. So I will expose it to the light, decrease the resistance, and we open the flow. It's kind of like opening a flow valve. So and that's why we have resistances in some of those connections. So some of them they fail. How do you test the resistance? Continuity. And also if they are labeled to know what is the resistance between them. So go there with the probes and make sure you have the right resistance. What could change the resistance? Can get old, can get burnt out, can just fail. So that's something you want to check. The harnesses here, those can also break or deteriorate with rust and also dust and debris. Slippage of the cam. That's the cam inside the modulated control motor. It can slip. Well, what can cause it to slip? If it goes too fast, it can slip and it will cause it not to time correctly, and the fire rate will be not accurate. Failure of the transformer. That's again easy to detect. It has a transformer from 120 to 24 volts. All right, I'll do class 2 on Tuesday. Please go over this PowerPoint simply that much, and that's all I need you to know. All the smokes.